Good afternoon, guys. Can you hear me clearly? Hello, guys. Can you hear me clearly?
Yes, sir.
All right. Today we'll be looking at permutations. Guys, we'll be looking at permutations and combinations today.
I can't hear you again.
How about now? Can you hear me now? Just a second. Hello, class. Can you hear me?
Yes.
So nobody's saying anything. You can hear me, Abby?
We can hear you, sir.
All right. Let's proceed. So I said today we'll be looking at permutations and combinations. So let's look at this one after the other. Let's look at permutation first. All right. So what are permutations? Permutations has to do with arrangements where order matters. Permutation has to do with an arrangement where the order matters. Order simply means how you are arranging it. Permutation simply has to do with arrangements where the order matters. Arrangement, very key word. Yeah. Very. Hello guys, can you hear me now? Class, can you hear me? Are you with me?
Yes, sir.
Yes,
Yes,
sir.
sir.
All
We
right, so
can
I had
hear
a little, I
you.
had a little bit of network issues. Right now, so as I was saying permutations simply means arrangement where the order matters. Now, one keyword under permutation is arrangements. Just whenever you are seeing arrange is most likely dealing with permutation. Now, let's take for instance, we are running a race. Bola carries first. Bola carries first, then Bayo second, and Femi third. Now, these are three different people. Their roles can't be interchanged. The arrangement really matters here because Bola is simply first. I can't just say three people carried first, second, and third. If we are dealing with permutation, I can't say three people carried first, second, and third. I have to specify which one carries first, which one carries second, which one carries third. Let's take, for instance, again, you have your ATM pin. Your ATM pin is usually 4 digits. When you are writing your ATM pin or when you are typing your ATM pin, the arrangement also matters. My ATM pin is, let's say, 4237. This is the arrangement of my ATM pin. I can't write this as 4327. It won't work. I can't write it as 7324. It won't work. So that's permutation. Arrangement really matters. The order in which it comes really matters. Exactly.
Yes,
Yes,
sir.
sir. Yes,
Yes,
All
sir.
sir.
right. Now, when dealing with permutation question, we have a simple formula to always use. We have the formula to be n permutation r is equals to, okay, before that, now we have something called factorial. We have something called factorial. Now, what does factorial simply mean? Factorial is simply the product of positive integers and okay, let me put it this way. Factorial is simply this product of positive integers and that of the positive integers that are smaller than it. Let me come again. Factorial is the product. That's you are multiplying the positive integers with that of the positive integers that are smaller than it. Let me just write it in the way you understand. Let's say we have this is the sign for factorial here, like an exclamation mark. This is the sign for factorial. So let's say you have 5 factorial. I was saying it is the summation, it is the product of a positive integer. This is a positive integer. 5 is a positive integer. Is the product of this positive integer and the other positive integers that are smaller than it. So if I check other positive integers smaller than 5, it is simply 4, 3, 2, 1. So we are multiplying everything. That's why I say it is the product of a positive integer and other positive integers that are smaller than it. If you are told to look for 5 factorial, it's simply 5 times 4 times 3 times 2 times 1. If you are told to look for 2 factorial, it's 2 times 1. If you are told to look for 4 factorial, it simply means you are counting down 4 times 3 times 2 times 1. Exactly. Hello guys, are you with me? Right
Yes,
now,
sir.
so our formula for permutation is simply n permutation R
Oh my.
is equals to n factorial over n minus r factorial. So you have to know this formula on your head. Very, very important. You need it to answer all questions regarding permutations. N permutation R is equals to n factorial over n minus r factorial. Don't forget, it's very, very important. N permutation R is equals to n factorial over n minus r factorial. Now let's look at some examples. Don't forget, how do you deduce the permutation question? It usually tell you to arrange in a specific order. Now let's take simple example first. Now let's say you are told to arrange 3 students. You are told to arrange 3 students from 5 students. Okay, from our formula, we say n permutation R is equals to n factorial over n minus r factorial. Now this n here simply means the total objects. The n here, where n is equals to total objects. And our R here is simply equals to the selected objects. This is it again. Our n in the formula is the total object, and our R is selected object, or whichever objects you arrange, that's what our R is. Now we are told now arrange 3 students from 5 students. Now the total object here is 5. Why the one we are arranging or we are selecting from is just 3? So how do I know it's a permutation question? I was told to arrange. Arrange is very important when you're dealing with permutation. We're told arrange. So how do I solve this? I just have to implement my formula. We say n is the total object. The total object here or total students is 5. While R is the selected object or arranged object. Selected object here is 3 students. So implementing that, we'll be having 5, which is our n, permutation R, which is 3. And this will simply be equals to 5 factorial. We have n factorial there, divided by n, which is 5, minus r, which is 3 factorial. And what do we say 5 factorial? You say 5 factorial is 5 times 4 times 3 times 2 times 1. But before that, subtracting this one down now, 5 minus 3 is 2. So I'll be having 2 factorial. I'm left with 2 factorial down. Now, whenever you're trying to divide factorials, sometimes you don't always have to like divide them to like break it down to the end. We'll solve these things, but let me give you an instance. We have 20 factorial over 18 factorial. Now, I want to divide this now. Instead of having to do 20 times 19 times 18 times 17 till the end, then divided by 18 times 17 times that till 1. What do? You simply bring this one. We are multiplying this 20 times 19. Then wherever this one, whatever is down, that's where we are stopping. 20 times 19 times, we have 18 factorial down. So we are stopping at 18 factorial. 20 times 19 times 18 factorial. Since I have 18 factorial up and I'm having 18 factorial down, I just have to cancel it out. 18 factorial will be cancelling 18 factorial. Instead of having to do 18 times 17 till the end, then 18 times 17 till the end, 18 factorial can simply cancel 18 factorial. So we'll just be left with 20 times 19 to get our answer. For me back here, so now instead of me taking this to the end, I can simply do 5 times 4 times 3 times 2 factorial divided by 2 factorial. So 2 factorial is cancelling out 2 factorial. Then we are left with 5 times 4, which is 20. 20 times 3, which is 60. So this is simply equals to 60 ways. So we can arrange these students in 60 ways. Is it clear, class?
Yes, sir.
Talk to. All right. Let's move on to a second example. Now let's say we are told don't forget. Right now, before we proceed, I want to make something clear to you guys. Now, 1 factorial is equals to 1. 2 factorial is equals to 2 times 1, which is equals to 2. 3 factorial is equals to 3 times 2 times 1, which is equals to 6. Now, how about 0 factorial? Whenever you see 0 factorial is equals to 1. Please note, this is what I want to point out. 0 factorial is equals to 1, not 0. Whenever you have 0 factorial, it is equals to 1, not 0. Right now, let's look at this question now. We are told how many two-lettered formed from A, B, C, D. What's our, we say our formula is, can be formed from A, B, C, D. And we say our formula for permutation. Now, how do I know this is a permutation question? I'm told arrangements. Now, we say our formula for permutation is simply N permutation R. Now, I have to always deduce my N and my R. What's my N in the question? Now, we say the N is the total object we are selecting from. If we check here, what's the total object we are selecting from? We are selecting from A, B, C, D. That's my 3, 4. So my N is equals to 4. Then what's my R? We are told to arrange two-lettered word, two-lettered arrangement. So my R is equals to 2. R is equals to 2. Implementing this in the formula, we'll be having 4 permutation 2. Now, what's 4 permutation 2? Is simply equals to 4 factorial over 4 minus 2 factorial. I'll be left with 4 factorial over 4 minus 2 is 2. 2 factorial. Breaking this down, we'll be having 4 times 3 times 2 factorial. I don't have 26, I have 2 factorial down. Divided by 2 factorial. Now, 2 factorial is cancelling out 2 factorial. 4 times 3 is equals to 12. So we have 12 ways. So it can be arranged in 12 ways. Is it clear, class?
Yes, sir.
All right. All right, let's move on to the next question. Right now, there's this kind of way permutation questions can come again. You can be told like this: in how many ways? In how many ways can people round a table. How many ways can 6 people sit round the table? In how many ways can, now if you look at these questions now, you observe we are not mentioning arrange there. There's no arrange at all. There's no arrangement. But whenever you see a question dealing with round, or they are sitting in a circle, or they are sitting round, whenever you see a question, as you just know it's permutation, it has a separate formula. Whenever you are solving a question that has to do with sitting round a table, or a chair is arranged in a round format or in a circular format, it has its own formula. What's the formula? It is simply n minus 1. Whenever you see a question like saying they are sitting around the table, this is the formula you're using. So whenever you're looking at a question, you always have to look, or is it talking about them sitting around? Whenever you see around the table, it is n minus 1 factorial. What's my n here? My n is simply 6. So I have 6 minus 1 factorial. 6 minus 1 is 5. I have 5 factorial. What's 5 factorial? 5 factorial is equals to 5
times 4
times
3
4
times
times 3 times 2 times 1. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is 120. So it is 120 ways. So there are 120 ways that 6 people can sit around the table. You know, the funniest thing is if you cannot, that does not make sense, but you can decide to start checking this one. But if you start checking 6, 5, 4, 3, 2, 1 to arrange it, if you continue like that, like rearranging it, 6, 4, whatever, you actually have 120 ways. But then mathematics is trying to bring out shortcuts to solve things.
Please.
Hello, class, is it clear?
Yes, sir.
All right, so don't forget, whenever they are sitting around the table, you use the formula n minus 1 factorial. All right, so a class activity just for 1 minute. In how many ways can 6 students stand in a line? In how many ways can 6 students stand in a line? So 1 minute, anybody that saw this, but in how many ways can 6 students stand in a line? Just 1 minute, guys. In how many ways can 6 students stand in a line?
120.
120. Okay, that is one person. Said 120 ways.
Stand in a line.
Yes, like they are on a queue.
Oh, okay.
10 more
120
seconds.
with
120.
120. 120. Okay. Let's look at it now. Now, how could we tell this is the permutation? This is the permutation question. Don't forget, you say permutation deals with arrangements. Let's say we have 6 students now. I have A, C, D, E, F. Let's assume this is their names now. I was not told arranging this question, but how can I tell this is a permutation question? Because we have 6 different students. A can decide to stand first, then in this format, everybody. B can decide to stand here. A is stand here. That's another arrangement. So obviously, you are simply told that this has to deal with arrangements. Are you with me, guys? We can decide to have B like this. Let's assume these are the names. We can decide to have B stand first. A, C, D, E, F. There are separate ways they can stand. That's telling you this has to do with arrangement. This is a permutation question. Is it clear, guys?
Okay.
Sir.
Now, how do I solve this? Now, we say it is a permutation question. We say the formula for solving permutation is n permutation R. Now, what is our n in this question? Our n is 6. N is equals to 6. N is the total student we are selecting from 6 students. Now, what is our R here? Our R is equals to 6. To why? Because we only have 6 lines that are to be filled. They are standing on a queue and they say they are just 6 students. What it simply means is that there are only 6 spots to be filled. Looking at this now, we're not told in the question, but we have 6 students and we say they are standing in a line. So what does it mean? It means there are only 6 spots to be filled. So our R is simply equals to 6. So implementing this in our formula, we'll be having 6 permutation 6. What's 6 permutation 6? 6 factorial over 6 minus 6 factorial. What's 6 factorial? 6 factorial is, okay, we have 6 factorial. Then down here, 6 minus 6 is 0. We'll be having 0 factorial. We see wherever we have 0 factorial, it is what? Guys, what's 0? 0? 1. Exactly. 0
1.
factorial is 1. So we're having 6 times 5 times 4 times 3 times 2 times 1 over 1. What's 6 times 5? 30. 30 times 4, 120. 120 times 3, that's 460 times 2, 720. Is that 720?
Jesus.
We need to back it up.
Can you hear me now?
Oh,
Yes.
Why
yes,
you
sir.
So
confused?
we have 720 ways, yes or yes?
Omo.
Yes,
I'm
sir.
with you. Exactly. Is
Yes,
it clear?
yes, sir.
Yes.
Yes, sir.
Exactly. So I guess you guys saw where the mistake was. This one, everybody said 120. I wonder where you guys got that from.
Not clear, please. Not clear.
Let's open our past question. For those of us that have the Unilag post-UTME past question. Page 27, question 8. Page 27, question 8. Can you see my screen? I'm sharing it on my screen now. Can you see my screen clearly, guys?
Yes, sir.
All right, so we see page 27, question 8.
Eh,
Now, looking at this question now, we are told in how many different ways can the letters of the word George be arranged such that the vowels always come together? We are told in how many different ways can the letter of the word George be arranged such that the vowels always come together? Now, before we do this, let's take it this way now. We are told, okay, let's say we are told there are 5 students. We have 5 students now. 2 of these 5 students are twins. Are you with me, guys? 2 of these 5
Yes,
students
sir.
are twins. 2 of these 5 students are twins. And those twins always sit down together in the class. Whatever we are doing, whatever arrangements we are doing, they always have to sit down together. Whenever you are told now, you are given a question that there are 5 students, you are trying to arrange them, and the twins always have to sit down together. What do? You first count the twins as a single one. You are counting the twins as one person. Now, that's what you do first. You count the twins as one person. So if you are counting the twins as one person, we'll be having just 4 students now. Counting the twins as one person, we're having just 4 students now. Solving for 4 students, we have 4 spots. So we are still having 4 permutation 4. If you do that, you'll be left with just 4 factorial. Just like what we did earlier, 6 permutation 6 will be left with 6 factorial. So we have 4 permutation 4. We'll be having 4 factorial. 4 factorial is equals to 4 times 3 times 2 times 1. That's for the 4 spots. Then this is equals to 4 times 3, 12 times 2, 24. 24. Now you are not done. You've gotten 24 now for the total for student. Now don't forget, we now have the twins too. Now for the twins too, the twins can decide that Taye sit down first, Can they sit down second, or Can they sit down first, Taye sit down second. So you always have to do their own 2 factorial separately. Let me come again. There are 5 students. We are reducing them to 4 because the twins always have to sit down together. Reducing it to 4 now, we'll be having 4 permutation 4, which is 4 factorial, which is 24. Now, you now always all have to take into consideration the fact that Taye can sit down first and Kenny should sit down second. Or Kenny can sit down first and Taye should sit down second. So that's a 2 factorial on its own. You always have to do that one to 2 factorial, which is equals to 2 times 1. Then this is 2. Then you're now multiplying it. You are taking the product of both of them. 24 multiplied by 2. 24 multiplied by 2 is equals to 48. Is it clear or is sounding strange? Hello, class. Is it clear or is sounding strange?
no.
To me, it's not clear.
It's clear.
It's clear to
No
you, it's not
problem.
clear, right?
We should take it
It's not
down.
clear. Let's look at this with this question we want to solve now. Now, looking at this question, now we are told in how many different ways can the letter of the words JUDGE? In how many different ways can George be arranged such that the vowels are together? So we want the vowels to be together. Now, this is it. Now, they're telling us we want to arrange this word now. And the vowels, we only have two vowels here, U and E. So the vowels always have to be together. Now, we have 5 letters here. If I was just put in the question, in how many ways can this be arranged? That I simply have 5 factorial. How did I arrive at 5 factorial? It is 5 permutation 5 because
Letters.
we want to arrange 5 letters in 5 different ways. So it is 5 permutation 5. And we say we are solving for 5 permutation 5. What you arrive at is just 5 factorial. That's if we were just doing this direct. But looking at the question now, we are told the vowels have to be together. Now, I told you using the last example that whenever you are solving and 2 people has to be together, that's why I was using Taye and Kendi as the example, that 2 of them always sit down together. So for this one, we are told the vowels have to be together. If you are having the vowels together, let's assume we have 3 vowels here. We are taking the 3 of them out, and we are having just 4. Let me come again. You count the rest. This is 1, this is 2, this is 3. Then if we say all the vowels should be together, we are counting all the vowels as just 1. So we'll be having just 4 here. If we're having another letter here, let's say W. We are counting the consonants as separate ones, but the vowels, since they are together, you are placing them as just one block. You're having them as just one block. We have our JUDGE. So counting this now, we have the first one, 1, 2, 3. Then we have our vowels as the same thing. That's 1. So we'll be having just 4 factorial. Is it clear to this point? Do we agree that it's 4 factorial?
Yes, sir.
All right. What's 4 factorial? 4 factorial is 4 times 3 times 2 times 1. And this is equals to 24. Now, I said we are not done now. We can't be rearranging this, but let me just show you an example now. Let's assume this is my spelling now, JDG. We are trying to arrange this thing. We are checking the separate ways this can be arranged. Let's say I have JDG, UE. Then I can also have JDG, EU. What this simply means is that even after taking those 2 as the last one, they can still be arranged in 2 different ways. That was how I was using the last sample and saying Taye can sit down first, Kehinde should sit down second. Or Kehinde can sit down first, Taye should sit down second. That's why I said you always still have to take into the fact that there is still 2 factorial separately. So after calculating for this first block, you always have to take, because you said the vowels are together, you always have to calculate for the vowels separately again. If we add 3 vowels here, we'll still have to calculate 3 factorial. If we add 4 vowels, we still have to calculate 4 factorial. But because we have just 2 vowels, we still have our 2 factorial, which is the E and the U. E can come first, U should come second, or U should come first, E should come second. So we're having 2 multiplied by 1, and 2 multiplied by 1 is equals to 2. Then we say you take the product of this and the product of this, simply equals to 24 times 2, which is equals to 48. So we can be arranged. I mean, they can sit down. So it's vowels. We can be arranged in 48 ways. Is it clear now?
Yes, sir.
All right, perfect. Right now, our foundation question, page 7, question 11. Page 7, question 11. Okay, page 7, question 11. All right, if you look at this question now, it's similar to the question we just saw finish. Page 7, question 11. Can you see my screen, guys? Can you see my screen?
Yes, sir.
Yes.
All
We
right, just
can.
1 minute for us to attempt it. The question is looking similar to what we just saw. Just 1 minute for us to attempt it, then we move on. Nobody's done, okay.
48.
48.
Wait.
Okay.
Yeah. 3.
Any other person?
Oh, so no, sorry. 24. Sorry. Let me
24. Any
24.
other person? All right, 1 minute. Let's look at it together. So we are
Just
told
40.
5 people. We are told 5 people are sitting arranged in a row for a photograph. We have 5 people. That's our n is equals to 5 people. Now we are told there's a couple and they have to sit down together. What are we doing? We are taking those couple as one person. We are taking those couple as one person, so it is reducing to 4 people. So apart from the couple, we have 3 other people. And we are taking the couple, 2 of them as one block. So adding the 1 to the 3 other people, we'll be having 4 blocks. So we'll be left with our n will be equals to 4 factorial. 4 factorial is 4 times 3 times 2 times 1, which is equals to 24. And I was now saying again that for those married couple now, they are taking a picture. The husband can decide to sit first, the wife should sit second, or the wife should sit first, the husband should sit second. It's just like you having A, B, C now. You want to arrange this in different ways. You can decide to arrange A, C, B, B, C, A. It goes on like that, on like that. But I can't be explaining how we are arranging the first 4 people. That's why we are just doing this part straight. And I'm now trying to elaborate on that second part that, okay, husband can come first or wife should come first. So we'll be left with 2 factorial for the other part. 2 factorial is 2 times 1. 2 times 1 is equals to 2. Taking product of this and this is simply equals to 48. It's even the same thing with the question we just solved. So yeah, that guy said 48 and then he changed his mind. Is it clear now, guys?
Yes, sir.
Yes, sir.
Yes,
Yes, sir.
sir.
Yes, sir.
All right, now. All right, now there's a final way for the way permutation questions can be set. There's a final way for the way permutation questions can. Now you can be told in how many ways can mathematics be arranged? In how many ways can mathematics be arranged? Now, in how many ways can mathematics be arranged? Now, we already know this is dealing with arrangement, so we are dealing with permutations. Now, how do you solve this kind of question? If this question was just a straightforward that has individual letters, just like George, now if you are told in how many ways can George be arranged, this is just 5 factorial. You're only taking 5 factorial. But whenever you are dealing with something like this, and the letters, some of the letters come twice. Whenever you are dealing with something like that, and some of the letters come twice, what do? You count the total of everything first. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. In our numerator, we're having 11 factorial. Then divided by, now you're not counting the ones that occur more than once. Looking at M occurs 1, 2. M occurs 2 times, so we have 2 factorial down. A occurs 2 times, 1, 2, we have 2 factorial down. T occurs 2 times, we have we have 2 factorial down. Then the other things occurs once. So what do? You just have to divide like this. I believe you should be able to finish it like this. But let's look at another one. We have book. If you are told in how many ways can book be arranged, doesn't mean these are different letters. You just do 4 factorial. But because they are the same thing, what do? You take the total factorial first, 4 factorial. Then you are dividing it by whichever one occurs more than 1. This one occurs twice, so we're having 2 factorial. Dividing this, we'll be having 4 times 3 times 2 factorial divided by 2 factorial. 2 factorial is cancelling. 4 times 3 is 12. Same with here, we'll be having 11 times, 10 times, 9 times, 8 times, 7 times, 6 times, 5 times, 4 times, 3 times 2 factorial. So 2 factorial is cancelling 2 factorial. Then we have 2 times 1 down, 2 times 1 down. Is it clear, guys?
Yes, sir.
All right, so that will be all for today. But just one quick assignment. Immediately after the class, I just want you to try something. Mississippi. You are trying to arrange Mississippi. Now, in how many ways can Mississippi be arranged? In how many ways can Mississippi be arranged? So you try this on your own and you send your answer to the group chat. In how many ways can Mississippi be arranged? So that will be all for today, and I believe you should be able to answer all questions under permutation because I looked at all the aspects permutation question can be solved. At this rate, if you're unable to answer anyone, don't let me say something wrong with you, but then, all right, that will be all for today. See you guys in the next class. Make sure you practice more questions. And does anybody have any other question? Hello, guys, any question?
No, sir. No
Okay, sir.
questions.
All right, that will be all for today. Don't forget, attend this. And also prepare for your test. So your test will come out in the next 1 hour. Exactly.
Yes, sir.
Hello, guys. All right, that will be all.